Hi everyone, today I would like to present my numerical programming project. My name is Kelvin Chai. My another groupmate is Lo Zexin. So let's start our presentation now. So look at the question 4.1. Find the nodal voltage of the circuit. So to find the nodal voltage, we need to know about the nodal analysis. The concept of the nodal analysis are the current entering equal to current leaving. So this is the solution for this question. So I combine it in the matrix form. So this is the matrix form. Okay, so this one is my part A and this one is my part B. And this V1, V2, V3 and V4 is what we should find the nodal voltage. Okay, so now I remove the A from the left hand side to the right hand side. So that my A will be the inverse A. So look at our MATLAB. So our A is 15, -4, 0 and -10 for the first row. And the second row, the semicolon is show us the second row. So my second row is -12, 27, 10 and -4. Semicolon for the third row is -5, 1, -1 and 5. Semicolon for the last row is 0, 0, 1. For B is 100, next row 0, next row 0, next row 10. So to find our voltage is inverse A times B. For line 34 is using the command fprintf. So the command fprintf will show the sentence in my command window. So let's run the program now. Okay, so the command will show the result. So this is the matrix of A, this is the matrix of B. So this is our result for the voltage for each node. So the fprintf will show this question. The voltage of V1 is 18.1107 volt, V2 is 17.9153 volt, and V3 is -22.6384 volt. So this is our question 4.1. Okay, our question 4.2 is use the mesh analysis to find the current flowing through the RB and find the power supply by the 10 voltage source. Now we assume all the loop is running in clockwise. So this is my first loop, this is my second loop, for this one is my third loop. So I arrange all the equation in the MATLAB form. So I let this part is the C and this part is the D. So I move the C to the right hand side. So the C will be the inverse C. Since we can get the I1, I2 and I3 so that we can find the current pass through the RB. So the formula pass through the RB is I3 minus I2 so that we can get our IRB. For the power supply by the 10 volt for the voltage source, which is the I1 for this loop. So then P equals to 10 times I1. So we look at our MATLAB code. Okay, so that this is our MATLAB code. The C is 40, -10, -30. The second row is -10, 30, -5. The third row is -30, -5 and 65. For D is 10, second row is 0, third row is 0. So to find our I is equal to inverse C times D. So for find the IRB is equal to I3 minus I2. For the power is 10 times the I1. So these three equations I showed it before in here, right? Okay, so let's run our program now. Okay, so this is our matrix for C, this is the matrix for D, and this is for the matrix for I1, I2 and I3. So the IB is we get is 0.0370 and my power is 4.7531. So I write in sentence is the current flow through the RB is 0.0370 ampere and the power supplied by the 10 volt voltage source is 4.7531 watt. So this is our presentation for the question 4.2. That's all for our presentation. Thank you for your watching.